Hey space enthusiasts! Welcome back to the channel where we dive deep into the universe's most intriguing mysteries. Today, we're uncovering something truly astonishing, something that was stumbled upon by the James Webb Space Telescope. Yes, we're talking about what appears to be NASA's darkest secret regarding Mercury, and it was revealed entirely by accident. Stick around as we explore what this could mean for our understanding of the solar system. The first image ever captured from orbit around Mercury was nothing short of breathtaking. As the data streamed in, the clarity and precision of the image surpassed our expectations. It was a pivotal moment, a confirmation that our spacecraft had gracefully settled into Mercury's orbit and our instruments were performing flawlessly. In a recent revelation, NASA has unveiled a chilling secret concealed within the depths of space, right on Mercury, our solar system's enigmatic neighbor. Although it sits dangerously close to the Sun, this small planet might appear modest at first glance. Yet, beneath its surface, marked by countless craters, lies a core shrouded in mystery and possibly diamonds. Prepare to explore the hidden depths of Mercury as we uncover truths both mesmerizing and ominous. These discoveries shed light on Mercury's covert treasures, long perceived as just a distant, blurry speck through our telescopes. However, with the advent of state-of-the-art technology from the James Webb Telescope and other missions, we are now peeling back this shadowy veil. Recent findings suggest something astonishing. Diamonds might be embedded within the very fabric of this scorching planet, but the wonders of Mercury extend beyond its sparkling potential. The planet's core, significantly larger than anticipated, holds secrets yet to be fully understood. Join us as we delve deeper into the mysteries that Mercury harbors, unveiling secrets as brilliant as they are profound. The deeper we delve into the mysteries of Mercury, the more its enigmatic landscape challenges our very understanding of planetary science. Each new discovery peels back another layer of this fiery world's secrets, revealing phenomena more bizarre and spine-chilling than we ever imagined. For a long time, Mercury's landscape remained an elusive enigma, shrouded in the shadows of our limited technology. But as our capabilities evolved, so too did our glimpses into this mysterious world. The journey to understanding Mercury began with NASA's pioneering Mariner 10 mission in 1973, marking the first significant step in peeling back its veiled surface. It was followed by a more ambitious endeavor, the Messenger probe, launched in 2004. As Messenger made its flybys, it captured images that unveiled a landscape pockmarked with craters and bizarre ridges reminiscent of our moon. The probe's findings were revolutionary, revealing a rough and cratered surface, a surprisingly strong magnetic field, and a core far larger than previously imagined. Then, in a leap forward 31 years after its predecessor, Messenger settled into orbit around Mercury, giving us a prolonged and detailed examination unlike any before. This dedicated orbiter captured over 200,000 images, each one offering a clearer view and deeper understanding of Mercury's hidden facets. Through these images, we continued to gather invaluable information, forever altering our perceptions of this enigmatic planet. As we ventured deeper into the mysteries of Mercury, Messenger provided us with unprecedented views of regions that had remained hidden from human eyes. One of the most striking discoveries was the unusually high levels of calcium and magnesium found on Mercury's darker side, a revelation that left scientists pondering the origins of these elements on such a barren planet. The probe also unearthed that Mercury's magnetic field exhibits unusual strength, particularly in the northern hemisphere, an anomaly when compared to other planets. On Earth, magnetic fields are generated by the movement of liquid iron within the core, but Mercury's unique interior composition gives rise to distinct magnetic phenomena. One of the most extreme aspects of Mercury is its temperature fluctuations. By day, the Mercury can soar to a blistering 800 F, hot enough to melt lead. Come nightfall, temperatures plummet to a bone-chilling -292 F. This dramatic shift is due to Mercury's thin atmosphere, which fails to retain heat. Despite these harsh conditions, recent data from Messenger, captured in 2012, unveiled signs of volcanic activity on Mercury, including evidence of explosive eruptions. This finding contradicted the long-held view that Mercury was geologically inactive. But perhaps the most astonishing revelation came in 2020 when scientists announced they had discovered the discovery of water ice in some of Mercury's polar craters has sent ripples of excitement through the scientific community. Despite the planet's proximity to the Sun, these shadowy craters remain so cold that they can preserve water ice. This startling find raises tantalizing questions. Could there be simple life forms on Mercury, surviving against all odds, much like the resilient organisms found in Earth's harshest environments? Imagine discovering life in the icy enclaves of Mercury. In 2018, the Bepi Colombo mission, a joint venture by the European Space Agency and the Japan Aerospace Exploration Agency, embarked on its journey towards Mercury. Slated to arrive in 2025, it promises to bring us closer than ever to Mercury's mysteries, offering a detailed examination of its surface, chemical composition, and geological past. Mercury continues to challenge our expectations with revelations like its robust magnetic field and hidden water ice. As we delve deeper into its secrets, we uncover a world where the rules of days and years are redefined, a planet where a day stretches longer than a year. But perhaps the most intriguing question remains: how does a planet so close to the Sun experience such a bizarre orbital phenomenon? This anomaly in planetary motion invites us to rethink everything we thought we knew about planets' behavior. As we look forward to Bepi Colombo's findings, who knows what other surprises Mercury holds in store? On the Sun's scorched surface of Mercury, the rules of time as we know them are completely rewritten. On this diminutive planet, a year races by in just 88 Earth days, a brisk pace that makes a Mercurian year much shorter than our own. Even more fascinating is that a single day on Mercury, defined by one complete rotation, stretches out to about 176 Earth days. This means that, incredibly, a year on Mercury is only half as long as a day. This bizarre time pattern gives rise to some truly unusual phenomena. If you were standing on Mercury, you would witness the sun rise, gradually swell in size as it approaches, pause, reverse slightly in the sky, and then resume its normal path. This odd celestial dance is due to Mercury's slow rotation struggling to keep pace with its rapid orbit around the Sun. But what causes Mercury to spin so sluggishly? Scientists attribute it to a phenomenon known as tidal locking. For billions of years, the gravitational pull of the Sun has been decelerating Mercury's spin. Unlike Earth's moon, which is completely tidally locked with Earth, Mercury is locked in a unique 3-2-spin orbit resonance. This means that Mercury completes 3 rotations on its axis for every 2 orbits it makes around the Sun. This unusual arrangement of day and year on Mercury leads to some of the most curious and extreme conditions in our solar system. Mercury's unusual day and night cycle creates some of the harshest conditions in our solar system. One side of the planet endures months of blistering heat, while the other side remains in freezing darkness for equally long periods. Adding to its strangeness, Mercury has an exosphere, a very thin atmosphere that is constantly escaping into space. This exosphere is continuously replenished by sources like the solar wind, radioactive decay, and micrometeorite impacts. But perhaps the biggest surprise came in 2020 when studies using data from the Messenger spacecraft revealed that Mercury's exosphere contains more water vapor than previously believed. This water vapor likely forms when hydrogen from the solar wind reacts with oxygen in Mercury's surface rocks. Another intriguing aspect of Mercury is how its long day and short year affect its magnetic field. Despite its small size and slow rotation, Mercury has a magnetic field, something scientists didn't initially expect. Recent studies suggest this magnetic field is generated by a unique dynamo effect in Mercury's liquid metal core, influenced by the planet's distinctive orbit and spin. Although weaker than Earth's, this magnetic field is essential for protecting Mercury from the relentless solar wind. Without it, the solar wind would strip away Mercury's already fragile atmosphere even faster, leaving the planet even more exposed to the harsh conditions of space. Mercury's rapid orbit around the Sun, combined with its slow rotation, creates some truly fascinating conditions on its surface. One of the most intriguing features are the so-called hot poles, where the Sun appears to pause in the sky. These spots are the hottest regions on the planet. In stark contrast, there are areas near Mercury's poles that are perpetually shrouded in darkness, never touched by sunlight. In these shadowed craters, scientists have discovered water ice, sparking the question, how can ice exist on a planet so close to the Sun? The answer lies in Mercury's unique spin and movement. Some craters near the poles are permanently shaded, never receiving any sunlight, which keeps them extremely cold. This creates a striking contrast to the scorching hot regions nearby. The discovery of water ice in these frigid areas has led scientists to speculate that other materials, like organic compounds, might also be preserved there. Mercury's swift orbit presents unique challenges and raises intriguing questions. Its rapid journey around the Sun, combined with its long days, influences how we study this mysterious planet. The speed of its orbit makes it a difficult target for spacecraft. To slow down enough to enter orbit around Mercury, spacecraft must follow complex trajectories, often involving multiple flybys of Venus and other planets to gradually adjust their speed and approach. Mercury's path through space and time is as complex as it is captivating, making it one of the most challenging yet rewarding destinations in our solar system. The Bepi-Colombo mission, launched in 2018, is currently on its journey to Mercury, skillfully using gravity assists to fine-tune its trajectory. After completing 9 flybys, it's expected to arrive at its destination in 2025. But the real challenge begins once Bepi-Colombo reaches Mercury. The spacecraft will have to endure the planet's extreme conditions, facing intense heat when it's exposed to the Sun and conserving energy during the long, freezing nights. Successfully managing these extremes is crucial for the mission's success and underscores the harsh environment created by Mercury's unique orbit and rotation. Recent studies have delved into why Mercury spins so slowly. It's possible that Mercury once spun much faster, but over time, the Sun's gravity and impacts from large objects like asteroids gradually slowed its rotation. This research not only sheds light on Mercury's past, but also offers valuable insights into how planets in our solar system evolve. However, new mysteries about Mercury continue to surface. For example, how does Mercury's core remain partially molten despite the planet's prolonged cold periods? And how does its unusual orbit influence its geological features? As Bepi-Colombo approaches Mercury, we look forward to uncovering more of these enigmatic secrets and deepening our understanding of this extraordinary planet. These questions remind us that even within our own solar system, there's still so much to discover. Mercury's unique characteristics challenge our understanding of planet formation and force us to rethink long-held scientific ideas. One of the most fascinating aspects of Mercury is its unusually large core. Dr. Nancy Chabot from the Johns Hopkins Applied Physics Laboratory found that Mercury's core makes up about 85% of its total volume, a stark contrast to Earth's core, which accounts for only about 15% of its volume. The reason why Mercury has such a massive core remains a mystery. One theory, proposed by Dr. Eric Asfog from the University of Arizona, suggests that Mercury was once much larger. According to this idea, a massive collision early in the solar system's history stripped away most of Mercury's outer layers, leaving behind the dense, iron-rich core we see today. This hit-and-run event might explain why Mercury's core is so disproportionately large. Another surprising discovery about Mercury is its magnetic field. Unlike Venus and Mars, which lack magnetic fields, Mercury has one, although it's only about 1% as strong as Earth's. This was one of the key findings of NASA's MESSENGER mission, leaving scientists with even more questions about the planet's mysterious inner workings. Scientists were puzzled by the discovery of Mercury's magnetic field, as they didn't expect such a small, slow-spinning planet to have one at all. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, and her team uncovered even more intriguing details about this magnetic field. They found that it isn't centered, but is shifted by about 20% of the planet's radius. This displacement could be due to variations in the thickness of Mercury's crust, which influence how heat is distributed within the planet. But the surprises don't stop there. In 2020, scientists made an unexpected discovery of volatile substances like sulfur, potassium, and sodium on Mercury's surface. These materials typically vaporize quickly under intense heat, so finding them on a planet so close to the Sun was astonishing. Dr. Patrick Poplawski from the Johns Hopkins Applied Physics Laboratory suggests that these elements might have been delivered to Mercury by comets or asteroids after the planet had formed. Mercury continues to astonish us, revealing secrets hidden beneath its surface. One of the most surprising findings was the discovery of water ice in craters near Mercury's poles, where the Sun's rays never reach. This discovery, coupled with the presence of other volatile substances, has sparked new questions about Mercury's history and the processes that have shaped this enigmatic planet. The shadows in Mercury's polar craters keep temperatures low enough to preserve ice, a discovery where Dr. Nancy Chabot played a key role. Even more fascinating is that these craters also contain organic compounds, carbon-based molecules that might resemble those that helped ignite life on Earth. This raises the intriguing possibility that Mercury could hold clues to the origins of life in our solar system. But the surprises don't end there. For a long time, scientists believed Mercury was geologically inactive. However, ENASA's Messenger mission revealed evidence of recent volcanic activity. Dr. David Rothery from the Open University identified small, bright areas on Mercury's surface that appear to be volcanic vents, suggesting that Mercury is still geologically active. Adding to the mystery, Mercury's south pole features a region known as chaotic terrain, a vast expanse of jumbled hills and valleys as large as Texas. This area was first observed by the Mariner 10 mission in the 1970s. Dr. Thomas Waters from the Smithsonian Institution proposes that this chaotic terrain might have been caused by powerful earthquakes driven by the Sun's gravitational pull as Mercury's orbit evolved over time. Scientists have also uncovered new insights about Mercury's internal structure. Dr. Amir Khan from the University of Zurich analyzed data from NASA's Messenger mission and discovered that, like Earth, Mercury has a liquid outer core and a solid inner core. However, Mercury's inner core is much larger in proportion, which might help explain its unusual magnetic field. These findings challenge our current understanding of planetary formation and evolution, reminding us that even within our own solar system, there is still so much left to learn. As we anticipate future missions and discoveries, the possibilities of what secrets Mercury might still hold are thrilling. One of the most fascinating aspects of Mercury is the structure of its core. Unlike Earth, where the core is mostly solid with a liquid outer layer, Mercury's core is mostly liquid with a solid center. The Messenger mission uncovered this by studying subtle changes in Mercury's gravity. The inner core of Mercury is particularly impressive, stretching about 1,260 miles, 2,000 kilometers, across, making up nearly half of the planet's entire core. In comparison, Earth's inner core only constitutes about 20% of our planet's core. This significant difference in core structure is one of many mysteries that makes Mercury such an intriguing subject for ongoing exploration and study. Mercury's core plays a crucial role in generating its magnetic field. While Mercury's magnetic field is weaker than Earth's, it is surprisingly strong for such a small planet. Beneath its surface, Mercury has a mantle layer that is much thinner than scientists initially believed. Recent findings suggest that Mercury's mantle is only about 260 miles, 420 kilometers, thick, significantly thinner than Earth's mantle, which is about 1,800 miles, 2,900 kilometers, thick. This thin mantle influences how heat moves within Mercury and impacts its geological activity. In 2012, a significant discovery was made about Mercury's surface layers. The MESSENGER probe found evidence of ancient volcanic activity, including shallow indentations known as hollows, likely formed as certain materials escaped from the planet's surface. This discovery suggests that Mercury may have had more volatile materials than previously thought. However, an even more surprising discovery came in 2020, when scientists analyzing MESSENGER's data found evidence of a massive ancient magma reservoir beneath Mercury's surface. This magma sea likely played a significant role in shaping the planet's geological history and surface features. Mercury's structure offers a glimpse into its complex and dynamic history. Unlike Earth, Mercury doesn't have plate tectonics, but it does show evidence of significant shrinking as the planet cooled over time, leading to the formation of numerous surface faults. These geological features add another layer to our understanding of this unique and intricate planet. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.